Looking forward to our presentation. Before we get to the main program, we want to hear from our sponsor, and you may know our sponsor by its former name, DTI, or DanChem. I'm ahead of myself already. Now the new name is DTI, headquartered in Danville, a custom manufacturer of fine and specialty chemicals and chemical products. It was founded actually from the research department of Danville Incorporated back in about 1960. And Wayne Smith is the Vice President of Technology and Commercial Development for DTI. Wayne's going to tell you a little bit about this firm. Wayne.
Thank you. It's good to see everyone. As you noticed, I don't have a presentation because when I left my office, the IT folks were there trying to get my computer to play nice. Apparently, I picked up a virus or something Sunday night, and it's not doing anything that I wanted to do. So, quickly, DanChem is a custom and whole specialty chemical manufacturer. We've been in this, my site's been in existence for 62 years. For the last 25 or 30 years, we've been in the custom chemical business. We have evolved from textile chemicals when we were part of the Dan River Mills system. Recently, to help our company grow, built what we call the Advanced Technology Center. And that has allowed us to put a pilot facility and a semi-works facility in a separate building at our site. And we opened that up in November, and it's been quite busy ever since. And we look forward to that generating a bunch of new business for us at DanChem here in Danville. So, thank you for letting us come and talk a little bit about our Advanced Technology Center, and I look forward to seeing the presentation. Thank you.
And thanks to DTI. DTI is one of the founding sponsors of the network. We've been in operation for about a year and a half, and now we're grateful to that firm that's based right here in Danville. Our presenter today is the director of the Center for Unit Load and Packaging Design at Virginia Tech. His education and research include master's degrees in wood engineering as well as engineering management, and he earned his doctorate in forest biomaterials from NC State. Some of his areas, and I'm just saying some of his areas of expertise include the interactions between package, pallet, and material handling systems, computer modeling, and the design of pallets and containers as well. If you think of everything that we use in our daily lives that is either packaged or palleted and shipped, you get a sense of the impact of his research. Please join me in welcoming Dr. Laszlo Horvath.
The Center for Unit Load Packaging and Unit Load Design was established in 1976, so we are operating for more than 40 years and serving the pallet packaging and unit load design industries. We have two main laboratories, the William Sordo Pallet Lab, and we also have a packaging materials lab, which was recently established in 2011. We have faculty in the center with various expertise. We can focus on packaging engineering, and that's basically one of my main areas. We also have faculty focused on pallet and unit load design systems. We have faculty focusing on bio-based polymers and bio-based materials to develop the next generation of packaging materials. And we also have expertise related to market analysis, so we can investigate various markets and see which market would be the most important for us to focus. And if you're interested in any other markets, then we can help you with that market analysis. The main missions of the center is to develop new information, mainly through research investigating the interaction between the different components of packaging. We're also assisting the industry mainly through contract testing and the continuous educational workshops. We do a lot of workshops when we teach the industry how to deal with the different packaging materials and unit loads and how to optimize the systems. And of course, because we are part of an academia, we are focusing on education of students. We do this through internships, experiential learning classes, and we have a packaging systems and design curriculum focusing specifically on total packaging. Our services include the contract services, unit load design and evaluation. So we evaluate pallets, packaging, fasteners, almost any part of the unit load. We also do total package evaluations, including primary, secondary packaging. We do sustainable packaging material development and characterization. And we do market studies for hire and industry analysis. We are an ISTA certified laboratory, so we do all the ISTA transport packaging tests to make sure that your product survives the distribution and it gets to the destination in one piece. We work for IKEA and other furniture manufacturers to evaluate their products. We also do research, and our research interest involves multiple different things. We focus on life cycle analysis, mainly about tertiary packaging. One of my students currently building a life cycle inventory for pallet recycling to fill the existing gaps to make sure that companies can evaluate their distribution system much better than what they can do right now. We focus on the interaction between pallets and material handling equipment, packaging and pallet interaction, so the next interaction within the unit load. We're looking at sustainable distribution system developments. We're looking at the whole system and try to see what are the opportunities and how we can improve the system. And then one of the new areas that we started to focus on is sustainable packaging material development. We are looking at how we can use bio-based plastics and natural fiber-based composites in various areas in packaging. Some of our historical work involves interaction between packages and pallets. This is a huge problem for beverage industry. We had multiple companies coming in 1 year after each other because they had seal failures. Because what's happening in distribution, you put beverages or oil in all of these boxes. If your pallet design is not stiff enough, then all the deck boards are bending down, so all the bottles are following that bending. So the bottles on the top of the string are experiencing 10 to 20 times higher stress than every other bottle. Therefore, if you design plastic bottles, your designer are not going to consider 10 to 20 times the safety factor. So some of your bottles start to fail. The problem is that if it's bleach, or even if it's soda products, if it arrives to Costco, open the container, see any of the leakers, immediately send the whole container back. And we had one of the beverage companies who started to experience 8% leakers from 1 year to another when they started to save more on plastic pallets. We're currently developing a model which is going to be built to one of the software packages which is developed by one of our professors to help the industry predict these stresses if you put various products on the pallet. We also investigated the effect of load bridging. So if you go and modify the stiffness of the package, if you go from brick blocks to bags filled with liquid, the bending of the same pallet starts to change. And that's a huge problem. For example, IKEA, their pallet is so stiff, they don't even need a pallet. They basically just put blocks under their unit loads to make sure that the forklift can go in and lift up the pallet. But some of the chemical industries, when you put super sacks filled with any type of chemical or plastic beads in it, that bends the whole pallet. That's a totally different ballgame. We measured out that you can see 70 to 80% reduction in deflection if you go from a less stiff package to a more stiff package, and that's a huge difference. We had companies when we tested plastic pallets and we found the pallet only can handle 1,000 pounds, but when we put plastic crates filled with beverage in it, it handled 8,000 pounds. That's a big difference for plastic pallets. Some of these findings were built into ISO 8611, which is one of the main pallet testing standards throughout the world, which is used to classify pallets globally. We also looked at vibrational characteristics, how the stiffness of the pallet influences the natural frequency. If you have a less stiff pallet, packages has a tendency to move more on the top of the pallet. They experience higher G-force, they fail faster. So if you go to a less stiff pallet, you start to see failures. If you go to a more stiff pallet, you are altering the natural frequency of the unit load, which also can create problems. So we measured it out and we started to work on a prediction model to help industries to mitigate these problems. Currently what we are focusing on, we are investigating what's happening if you have different stiffnesses of pallets, and then you put packages on the top, and you modify the gap between the deck boards and how the strength of those packages goes down, because there is absolutely no information on that. We also have a vacuum technology project, which is really huge. We have the heat treatments that we need to apply for all the wooden pallets to make sure that we kill the bugs if we want to transport them nationally. It takes up a lot of money. It's a lot of cost. With using vacuum and steam, we can reduce the time of that treatment significantly. We can treat basically a lot of plastic pallets in 45 minutes rather than 12 to 14 hours, which is a lot of time saving. And we are currently moving up to a pilot scale evaluation of this technology. We also look at fundamental equations to improve load stabilization. When you put all your boxes in a pallet and you apply stretch wrap to keep all the loads together to make sure that they don't fall apart. At this point, it's just a hit or miss. You apply stretch film. If it's not good enough, you apply more. If it's still not good enough, you go with a higher grade, you apply more. And you do this until your product is safe. You do measurements to make sure that you comply with certain regulations, but those regulations mainly coming from companies, and you use it because you tried it and it was working before. One of our students worked on mathematical equations that you can actually measure the stretch film, the stiffness of the stretch film, the tension, the modulus of elasticity of the stretch film, measure the thickness of the stretch film, set up how many layers you apply, what pattern you apply, and it's going to tell you how much containment force you're going to get in the unit load. So you actually can design these unit loads from now on. You don't have to just do the hit or miss process. We are also looking at focusing on bio-based composites and see how we can reinforce existing plastics with natural fibers. And we are also part of the physical internet initiative, which I'm going to talk about a little bit in a couple slides later. This is the first one that I was talking about, deck boards and pallets. Currently what we do, we put wooden boards under the boxes. We leave a certain gap. We crush them, measure how much reduction we see. This is as far away from reality as possible because you don't never see deck boards like this. You always see thin ones. They always bend. Then you have bending this way, plus you have that gap. And that creates a lot of problems. Current design methodology doesn't really consider this at all. Physical internet is a really interesting new idea. It's basically, we found that there are a lot of problems with shipping. First of all, we ship a lot of air. 20% of the trailers are basically empty when we ship them because we cannot fully cube them out. We also have problems that empty travel is almost a norm. You ship products to one place, you have to travel empty until you get to another destination, pick up new products. Truckers become modern cowboys. Basically, if you want to ship something from Blacksburg to San Francisco, you hire a trucker, poor person drives to San Francisco, drop something off, try to look for something that he can use to come back. And this is not really acceptable because those people don't really have a life. They basically just travel around throughout the whole United States shipping your products. Fast and reliable multimodal transportation is also a big problem. It doesn't exist. We have containers. We have some way of efficiency that we can move containers from one place to another. For example, from container ships to trailers, then to rail. But it's still not efficient. And then we have weight carrying capacity differences. Like Caterpillar, when they ship engines, they actually fill the containers with 65,000 pounds. When it gets to the port, they have to remove 25,000 pounds, and then they put it on a rail system or a flatbed trailer, and they ship it to their facility. So they actually have to remove products from containers. So it's still not the full multimodal transportation. Smart automation technology is hard to justify. Everything needs to be cheap. Nobody really uses global systems to coordinate all the transportation. If HP and Apple want to ship products, they're going to ship it in 2 different containers, even if you could combine them without any problems. So what we looked at an idea that how we can look at the internet, as we know right now, for data transfer. We have specific units transferring the data. Your data travels next to your competitor's data because you're using the same system. So multiple universities in the US and in Europe are looking at this system, and we see how we can actually move it to physical internet, that we have containers which are data units basically. You just fill it with products, and it doesn't matter if it's just yours or your competitors. You just put all the products into one container, it's shipped to a dock, and then you might clamp it together with other containers. So you have these mini modular containers, different sizes, and then you assemble them together like a Lego unit to ship it together to the destination. It helps a lot with smaller urban shops. Like Target has a lot of problems. They have more and more Targets in downtowns, like Chicago. It's a nightmare to get there with big 18-wheelers. So if you have these smaller modular containers, you don't have to take out everything from the container and put it into a smaller pallet and ship it to the store. You actually can just detach some of these modular containers, and you can move it into a smaller delivery vehicle and just take it into downtown. We already did some pilot studies. What's happening if you start to do the standardization and start to remove all the different sizes of packaging, and how efficiently you can do this. What we found that if you have, some of the companies have, you can see almost 500 different products, and then 258 packages. So basically they design a package almost to every second product. Then they use these packages and palletize them and try to figure out how to fill the trailer more effectively. If you reduce the 258 cases into 15, which is a significant reduction in the number of packages, you don't have to store all the different ones, you lose 10%. You basically started to increase your cost. But if you go into the pallets, you can utilize the pallet more effectively because all those packages are designed specifically to fully utilize the surface area of the pallet. And at the end, you actually gain 10%, even if you lost 10% in the packaging side, but in the palletization side, you gain 10% because it's much more efficient to ship these in pallets. The next scale up is that you have these pallets and you fill trailers and you fill containers, and you do this even more efficiently so you can save more money. So what our part in this whole physical internet initiative to look at the container design, what the size supposed to be, how these modular units supposed to be built, how they're supposed to be clamped together, and how we can ship them more effectively. And this is really important because nowadays containers are metal. One of the requirements of the physical internet that needs to be light and made of environmentally friendly materials. So some of these bioplastics or some of these light plastics reinforced with natural fibers could be a great alternative to the shipping containers. And if you think about how many shipping containers we have, this is a huge thing. And now that we are still considering which is more effective to, whether it's more effective to ship these products to the destination and bring them back empty, maybe collapse them, or just ship it to the destination, and like the data units in the internet, they just disappear. You put them into the recycling stream, you recycle them, use it for other products. You don't have to ship them back. Then that would allow us to finally not to have to think about how to build houses out of non-usable metal containers, what we are doing right now, because in the US we have containers piling up at the ports because we cannot ship them back because we don't have products going back to the same country. Plastic pallets are also an alternative. In 2009, Modern Materials Handling magazine talked about the rise of plastic pallets, that everybody started to use plastic pallets, it started to be the dominant pallets. Fortunately, we have a long way to go, because as I mentioned, plastic pallets are not as stiff, they are still expensive. If you want to use plastic pallets, you have to have reinforcing metal bars in the pallets, like the IGPS pallets, which is a hassle because people are going to steal those pallets, take out the metal bars and recycle them. We had some of the companies, they actually invented methods how you can put together the two injection molded pieces in a way that it's impossible to take it apart, for make sure that people don't steal pallets. People love metal pallets. We had aluminum pallets recently tested. Some of the companies told us that they don't even ship them to China because people steal them from warehouses and recycle them. So what we are currently looking at is see how we can put fibers into plastics and reinforce these plastics, basically make fiber reinforced composites. Some companies are working with fiberglass recently. And fiberglass has been around for a long time. People are experimenting with it. One of the problems with fiberglass is that it's not really safe to use because in a warehouse settings, because in warehouses you have a high tendency that you damage pallets. Once you damage a pallet, you have fiberglass sticking out. Workers go there, grab it, they get injured. Like when we test fiberglass pallets, students are using leather gloves and it still goes through the leather gloves. So they always have like glass fibers in their fingers. The next problem is, which is still debatable, but if fiberglass goes on the floor and it's actually become airborne, if you inhale it, that could be a potential safety problem again. If you use natural fibers, like cellulose fibers, this problem disappears. Cellulose fibers are strong, especially nanocrystals. When you break down cellulose fibers using acid hydrolysis into small crystallized units, they kind of look like carbon nanotubes, which has a modulus of elasticity of 150 gigapascal, which is the same as Kevlar. So basically Kevlar-like components that you could use to reinforce plastics. And there are a lot of studies reinforcing different plastics with nanofibers. Everybody's working with nanocrystals from wood. But plants also have a potential opportunity to extract these nanocrystals and put them into plastics and reinforce plastics with natural materials rather than reinforce them with fiberglass. Gluing systems are also important. We had a pallet design which is fiberglass reinforced. The glue is the problem. It basically breaks at the glue instead of breaking at the fiber. So we are looking at these fiberglass reinforced plastics, and we're also looking at what's happening if you start to use PLA, which is nowadays is not commercially feasible because it's expensive. But in the future, when we start to have standardized sizes, and first of all, the price of the oil is going to skyrocket, then these are going to be the only options. So we need to be ready, that we have all those materials ready and well developed by the time we start to switch to natural plastics, either because of regulations or because of the price of the oil. So these are some of the applications that we are looking at. And these are just lists of why natural fibers are great, because they are light, cheap. They are really, really cheap to produce them. High specific gravity and modulus. If it's come from certain plants, then it's a non-competing product with food if you don't use corn for it, because if you use corn, that could be a potential problem. So other than research, next thing that we are doing short courses. We teach all the knowledge that we obtained to the industry. Currently, we have two main short courses, mainly about wooden pallets and unit loads, and wooden pallets is transforming into plastic pallets. We teach everything else. So we show people how to design pallets to get into this potential market. We also teach unit loads, when you can look at how to optimize the package, pallet, and material handling system, and how you can make your distribution more effective. And a lot of companies are coming because so many people have problems. You always get emails that some company not even related to pallets have problems with unit loads failing. And then they come to the short course and they realize that, what the problem could be, and they go back and solve these problems. To sponsor research, we have an industrial affiliate membership, when we collect money from industry and basically share the research expense among multiple people. And then we develop those research opportunities and the research projects. We also help with employee training, because we have students trained in the lab working on different pallet designs. So they can go out to the industry and they can start producing value. And this is what basically the next slide is about. We just started a Sustainable Packaging Designer Trainee Program, which is a great program. Students get into this training program, go through a 3-month summer internship, learn everything as possible about pallet and unit load design. Then they work for 9 months for the center part-time when they are doing their studies, taking 2 classes about management, leadership, different regulations, the different standards, packaging design. And then in the last semester, they work on industry projects. So when they go out, they are fully trained in continuous improvement. They know all the possible standards, and they can go out and get internships at industries and solve problems. The great thing with this, that all these guys are freshmen and sophomores who are coming into the program, so they have zero knowledge when they come in, and they have a lot of knowledge when they leave. One of my students already got a job offer from one of the companies to be a plant manager when he graduates, and he's a sophomore. So he has a long way to go, and he already has a signed offer to go to that company, because they saw the transformation of the lab and all the knowledge that he obtained. So this is just an interesting program that we are currently working on to give more knowledge to the students and make them ready when they go out to the industry. So thank you very much for your attention, and if you have any questions, feel free to ask. It's probably going to take a little bit. It's going to be accelerated if the physical internet becomes a reality, because then all the different sizes go down to 1 or 2 pallet sizes. So immediately, everybody starts to produce that particular pallet, and the amount of plastic pallets goes up. So the price immediately goes down, because you can produce them more efficiently. So you can afford putting more and materials in it, especially if other companies start to adopt the Wal-Mart scorecard. Like Wal-Mart pushing everybody to be as sustainable as possible. They have big sustainability meetings. If you're a supplier of Wal-Mart, they tell you to be there. It's basically a mandatory meeting for every supplier. They invite a bunch of companies, and you have to visit all the companies, and they basically forcing you to reduce the packaging cost. And at the end of the meeting, they tell you that now the new trend is 5% less, period. You either do it or you're out. So if other companies, bigger companies, start to do the same thing, then it's going to push biodegradable plastics a lot into the industry. It's not a requirement. Still, CHEP is one of the main standards. I know that a lot of Wal-Mart companies using CHEP pallets because of economics, that CHEP pallet is still cheaper than anything else because you can circulate it back. But the other problem is there's only one pooling company producing plastic pellets, and that's IGPS. And IGPS is currently transforming into something new because their pellet wasn't really the best. So they are looking for a new design to compete better against CHEP. So we'll see. I know that a lot of companies who are sending pellets to us, they are selling pellets, try to sell pellets to IGPS. So it seems like there's a big buzz around plastic pellets, and people try to get into this market. Some of the companies even put combined plastic with rubber. I just read that there's a company who is coming out with a new resin which has used tires in it to make the plastic cheaper. And they claim that it has the same strength than every other plastic pellet.
Any other questions for Dr. Horvath?
Yep.
How much lighter in ballpark percentage do the modular containers need to be compared to a big metal container, especially they're on the wall?
Yeah. Yeah, they need to be much lighter. It's I don't have exact numbers for it, but they definitely need to be much lighter. Probably, yeah. That's one of the reasons why metal is not going to be feasible anymore. I know that ULDs, the unit load systems on airplanes, they were aluminum, and now they are going to plastic because they have to reduce the weight as much as possible. Same exact thing going to happen with containers. It needs to happen because containers are bulky, heavy. We have to start reducing the weight, especially with the smaller containers. Like in Europe, we have quarter pallets. These are these tiny mini pallets. So in some of the stores, they don't want to bring big, bulky 48 by 40 pallets. So they basically almost chop it into 4 pieces, and then you have these quarter pallets. And you see these small displays sitting on a pallet in the store. So companies are going to smaller and smaller units. And especially Target going into downtown Chicago and other big cities, they have to start figuring out ways to ship products effectively rather than using parcel. Parcel is the most expensive way of shipping among all the others. So every time when you have to break down a unit load and you have to put products one by one into a trailer, that's the most inefficient way of shipping products. So that's why these modular containers needs to be accurate. And I cannot recall the numbers, but I know that Europe started to adopt and go towards physical internet a lot. The US is still behind a little bit. And they calculated how many millions of tons of gasoline you can save just by reducing the weight of everything that we ship. Because transportation is a $30 trillion industry, so it's a big industry. And if you can make savings on it, it immediately helps for everybody. Yep. Oh, okay. Okay, a lot of our students getting internships. I know that especially everybody who works for a Center for Unit Load Design gets at least 1 or 2 internships before they graduate because they need to go out and they meet with a lot of companies, and that's how 2 of our guys who worked for PCA basically went into both of the guys, started the internship, and then they branched out and they investigated other industries. And I know that one of them is currently interning for another company too, so they are gaining more and more experience. But experiential learning is a really important thing in our curriculum. The whole curriculum is built in a way that students can go out and get internships, and we are currently thinking about how we can build co-ops into the program to make sure the students can go out for 6 months and work fully for a company. So these internships are really important, and they gain a lot of knowledge. I know that all of them who comes back, they pretty much know the industry, and they try to switch it. So they go to plastics, then they go to corrugated, then they learn about the unit load within our center. So we try to diversify them as much as possible. So when they go out, they're not just looking at one specific component and they're going to be the pallet people, they're going to be the people who understand the whole system. Yeah, thank you.
Different ways, IKEA, Wal-Mart, and everything else that we use. Just to let you know, 4 weeks from today will be the April meeting. But first, robotics, the presentation. The director of that organization, she's coming into Richmond. It's getting high school kids interested in science through robotics. We have a couple of teams locally here, George Washington and Chatham High Schools, so just 2 examples of how we're involved in that program on Commonwealth applied level. Please get to know the people at your table. Thanks again for attending.